Hello my dear champions, welcome back to our channel Diksha Karnataka. Today I'm here with your Masterstroke class for the chapter 3-dimensional geometry. Okay, so again a very straightforward chapter, formula based approach questions are there, whether it is KCET or PU2, both of these are on the formula base. In PU2 there is a derivation that comes, so what more or less the question are based on formulas only. So we will see the formulas, we'll learn how to apply them. I have taken some questions also to solve. So it will be a short session, we'll cover up everything quickly and then complete our class at one go. Now before I start, do not forget to subscribe to our channel and keep the notification bell turned on so that you don't miss any of the classes, because classes are very important right now. You don't have much time to come back and create the backlogs that you have. You have to cover the classes at the same time once they are released on our channel. Okay, now before I start, I have a surprise for all of you, and that is regarding your free KCET mock test. Yes, these are the 4 free KCET mock tests that we are giving to all of you. Because we understand this time is very important to solve question papers, mock tests. So we have given all of you, I hope you have taken already for free, but yeah, physics, chemistry, maths, biology, one paper each you can avail over here. So simply I've shown you with the help of the chapter integration. You can go and check in this class also, you'll find this link given over there. Free KCET PCMB mock test PDF. Okay, click on the link, this will appear. Simply enroll, or simply this is completely free. Just fill your details and get the access of PDF which has questions and answers both. Okay, you'll get 4 total mock tests for free. Avail right now, and with this I can start the class. Okay, so the first thing, we already discussed this in the vector algebra, but yes, over here also let me recall this about direction cosines and direction ratios. Okay, so if you talk about direction cosines, as it mentions, it is the angle made by a vector or line with x, y, z axis, because we are talking about 3-dimensional geometry now. So angle made with x axis if the angle, let's say, is alpha, with y axis if the angle is beta, and z axis if the angle is gamma, then this value cos alpha, cos beta and cos gamma is called as your direction cosines. Okay, so this is given by the value L, M and N. You already know that very well, and we have a relation also for this. What is the relation? Squares of this, sum of the squares of this DCs is always 1. Okay, what about DRs? So DR, when you talk about DRs, there is a constant involved. Means if I use LMN to write our, let's say if I use L as the component across x-axis, M as the component across y-axis and N as the component across z-axis, then Li cap, okay, that was but the part was in the case of your vectors, but it has a role to play here as well. So Li cap, M, J cap and Nk cap gives you the unit vector across a vector. Let's say if it is the vector is, if the line, if I talk about QP as vector U, then this will be your unit vector U cap. Okay, whereas if you take direction ratios, there will be a constant involved, and that constant goes like this. Check here. So the ratio will be constant, L by A, M by B, N by C. If I take this constant to be constant R, then what happens is, in this case we have taken it as lambda or lambda, then L becomes A lambda, sorry, yeah, my bad, not lambda, 1 by lambda, right? Yeah. Then what happens is your L becomes, check this out, you can get A value as lambda L, B value as lambda M and C value as lambda N. This constant is multiplied, and that is the difference between the direction cosine and direction ratios. Okay, so L, M and R direction cosines and A, B, C values are your 3 numbers, such that this constant of L to A, M to B, N to C are always a constant. We take it as either R or 1 by L to justify in this form: A as A lambda L, lambda B, lambda M, B as lambda M and C as lambda N. Okay, now direction cosine of a line passing through 2 points. Means if you have 2 points mentioned with the coordinates x1, y1, z1 and x2, y2, z2, how can you find direction ratios? Very simple, just find the difference of these two. So you can either take in the order of x1 minus x2 or x2 minus x1. Just remember, if you take x2 minus x1, same will go for this y and z also. If you're taking x1 minus x2, same goes for y and z as well. So you can take either this or this, your choice. Okay, now once you have this value will be your direction ratios. x2 minus x1, y2 minus y1, z2 minus z1 are your directional ratios. And what is direction cosines? Once you have this value, simply find this result, length of the PQ. Find this result. Okay, once you have this result, means squares of the drs that you got and taken as sum in the root, that value if you divide to the respective drs, okay, let's say if I call this dr to be a, b and c, then basically this result is what? A upon square of a, b and c taken as sum, b upon same thing and c upon same thing. Now this will become your direction cosines. So drs are abc, so basically x2 minus x1, y2 minus y1, z2 minus z1, but the dc's, the direction cosines lmn will be what? A upon this value, a square, b square, c square in the root taken as sum, and same b upon this for m, c upon same root for n. Is it making sense, guys? This is your understanding of direction cosines and relation between direction cosines and direction ratios. Okay, now in the knowledge hub, let me summarize everything once, because it is very important, because this results will help you solve MCQs in PU2 and questions of course in KCET. Check. The first result is very simple. Squares of L, M, N taken in sum is always 1, but this is not possible. This is only true usually the value of this a square, b square, c square is always equal to a constant k square. Okay, it will be equal to 1 when a, and this becomes equal to 1 when a is equal to L, b is equal to m and c is equal to n. When the direction ratio and the direction cosines are same, okay, then only this will be equal to 1, otherwise it will be always equal to some constant k square. Okay, in this case remember L lambda square or r square, whatever is the condition. Direction cosines of directed lines are unique, but direction ratios are not unique. So L, M, N values are always unique, but direction ratios A, B, C are not unique because you have a multiplying factor r over there. Okay, depending upon the value of r, the ratio will keep changing its position. Okay, now direction cosines of a line can always be called as direction ratio, means DCs can be called as DRs, but not vice versa. Only when this condition is true. Whenever the direction cosines, whenever the direction ratio are calling or being called as direction cosines, it means A is equal to L, B is equals to M, and then C is equals to N, then only this rule will be true. Clear, guys? Okay. Now, since x, y, z axis pass through the origin and have direction cosines mentioned like this for x axis, how come this is true, sir? Think about it. X axis, angle of x axis with x axis will be what, beta? 0 degrees. With y axis 90 degrees. With z axis also 90 degrees. What are these? These are the angle by the x-axis, or between the x-axis with the x-axis, with the y-axis and z-axis. So if you take cos of these angles, you'll have value as cos 0 is 1, cos 90 is 0, and cos 90 is again 0. This becomes your direction cosine of x-axis. So for x-axis we have 1, 0, 0. For y will become 0, 1, 0, and for z will be 0, 0, 1. These are the coordinate axes. So these are the direction cosines of the x, y, and z axis given in that particular order. Okay, and the equations will be what? For x-axis y0 z0, for y-axis x0 z0, z-axis x0 y0. Of course you know this very well, but these are usually very, very useful in the question solving, okay, problem solving. That's why I've kept this all in the knowledge hub. Now I have some surprises for all of you. I want to tell you all about our launch of KC30 combo batch. What is KC30 combo batch? Basically what happens over here is a combination of KC30 batch alongside your ABHYAS KCET test series, one of the best test series for KCET. Means over here you get 10 mock tests for physics, chemistry, maths, biology, and here you get 35 mock tests for physics, chemistry, maths, biology. If you combine these prices are going to be 3,999. Offer is only valid till 25th Feb because something is coming. Vidya Utsav is there. So this is the offer that is regarding Vidya Utsav. So wait, 21st February we have more surprises coming for all of you. So be there on 21st Feb to get to know about all of these things. Okay. So this is not, there are many more additions in that. Okay. Regarding, of course, the features are over here. You can see that this is KC30 combo or plus batch where you get access of both ABHYAS KCET alongside KC30 batch. If you want only KC30 batch, these are the offerings. things. You get live classes for 30 days, KCET previous year question papers you get, complete syllabus coverage for PU1, PU2. Yes, PU1 also will be covered. First actually we'll cover PU1 after your boards are over. Then we'll move on to PU2 syllabus. Chapter wise KCET, PYQs in the test format. So you can attempt the PYQs as a test also. This also is available in our platform. For 10 full length KCET mock tests, I already mentioned that, and the course commences on 21st March. Means the enrollment has begun at the price of 2499. You can enroll right now, but later the prices will increase because there's some offer going regarding Vidya Utsav right now. Once that Utsav is over, your prices will get back to the higher side. Okay, so you'll have to, if you want to enroll, you can enroll right now. Link for all these courses will be given in the video's description. Okay, so clear, KC30 is clear, KC30 plus is clear, 30 plus is alongside your ABHYAS and PU2 KC30 together. Okay, that is KC30 plus or combo batch. Now, equation of a line through a given point, this derivation is, I was talking about this in the beginning, that this derivation can be asked in your PU2 boards. This is derivation. PU2 boards ask the derivation, and in the KCET you don't have derivation, but you have questions on this, of course. So Cartesian form, if you have a line, let's say line AP given parallel to the line B, so B is a known condition and line A is, what is it? Line A is point A is coordinate, and the vector position of the point A is given as vector A. Okay, so then you can write this in the vector form as the resulting vector of any arbitrary point. The resulting vector of any arbitrary point is given by vector A plus lambda vector B, because this is parallel to B, right? So I can write, this is your vector AP actually. What is vector A? Vector A is your OA vector. So if you add OA and AP, you'll get what? OP. This is the triangle law of addition you use to get R as A plus lambda B. How you write A? So you can write A as simply xi cap, yj cap, A as x1 i cap, x2 y1 j cap, and z1 k cap, and this lambda B will be whatever the B component. So we have LMN over here, so LMN. This is the vector form and this is the Cartesian form. And what is parametric form? Whenever both are equal to, all of these are equal to parameter R. Okay, this is the parametric form, x in terms of LR and the coordinate x1 and so on. Got it? This comes from where? From the Cartesian form directly. I have taught you proof of this at many times, okay, in my classes where I have taught you questions. Even in 0 to Hero I taught you the proof of this question. But yeah, proof of this one comes in PU2 boards. Question on this comes in your, of course, both examination. Now, let me solve a question on this. Find the Cartesian equation of the line with the point passing through that point O for the point A, and this is the parallel. Parallel means I can write the vector B. Vector B will be, check here, vector B will be having 3i cap minus 6 j cap and plus k cap. Okay, if you're writing this, you'll have x minus 1 by 3 equals to y plus 2 by minus 6 and z minus 3 by 1. Okay, so you can check here, if you take in this format, it will become z equal to 3 only, because if this 3 goes over there, if you take equal to some parameter r, let's say, or 1 equals to, you'll get that result only. So answer is option C. Okay, z equal to 3, because we have z equals to 1 form over here, so we can write z equal to 3 form over this, but we need to put here a comma sign then. Okay, clear guys? It will be z equal to 3, not minus 3. Option is C. If it was z plus 3, then it will become z equal to minus 3. Difference is there. So no D. Now next concept is angle between the two lines. First concept was learning DCs and DR. Next was what? The derivation of a line passing through a point across and parallel to a given line, and then we had the Cartesian and vector form. And this is the angle between two lines. Okay, so if any two lines are there, you will have their direction cosines known in that case. And if it is given in the terms of your unit vector, I mentioned that already, if you remember. I mentioned this in the first slide itself, that if you use LMN, you get the result as your unit vectors. Okay, so if you have unit vector of alpha and beta, then of course alpha mod will be what? 1 only, no? If alpha is a unit vector, what is modulus of unit vector? 1. So alpha and beta is 1. This formula we know from vector algebra. Cos theta is A dot B upon mod A into mod B. So A dot B will be what, beta? L1 into L2. You can multiply I dot I, M1 into M2, N1 into N2. You get this as the numerator. What about denominator, sir? Mod of alpha is 1, mod of beta is 1, because they are both unit vectors. So you get the result as simply L1, L2, M1, M2, N1, N2. This is what? This is angle between two lines where the direction cosines are given. For two lines AB and CD, what is given? For two lines AB and CD, what is given? They have given us direction cosines. So if direction cosines are given, the angle between them will be given by L1, L2, M1, M2, N1, N2. So basically your theta becomes what? Cos inverse of L1, L2, M1, M2 and N1, N2. I'll repeat again, this is only for the case of direction cosines given, not direction ratios. Either direction cosines you can mention, or you can mention that the vectors are what? Unit vectors. Okay, then only this magnitude will be what? 1. Otherwise, now this was a concept from the dot product. The same thing we're trying to get from the cross product also. Okay, because we can get the result from here, beta, that if the theta 90 degree, it means AB is perpendicular to CD. What will happen? Cos theta will become 0. Theta is 90. It means L1 one second, guys. So L1, L2, M1, M2, N1, N2 becomes equal to 0. So if you have two lines given as perpendicular, then the direction cosines product will be always equal to 0, because cos theta is there. So cos theta becomes L1, L2, M1, M2, N1, N2, and that is 0 because cos 90 is 0. This is the result using perpendicular vectors. Now if I go to the, check here, perpendicular vectors. If I go to the parallel ones, for parallels we'll use the the concept of same thing on the direction cosines of what? Cross product. Check here. Cross product is given by what? Sin theta is A cross B mod by mod of A into mod of B. We know very well mod of A into mod of B is what? These two are 1 into 1, because mod of alpha and mod of beta is 1. They are both unit vectors. What about A cross B, sir? How do you find A cross B? You find using this determinant. When you do that, across I cap you're going to get M1 N2 minus M2 N1. Same way, solve this entire thing, you're going to get this as my result for A cross B. I'm looking for modulus of A cross B. So find the modulus of A cross B. You'll get squares of each component added under the root. This value is coming. Now, so this is your A cross B value. So if you want to get sin theta, simply equal to A cross B. But will we write all of this, sir, all the time in the question? Usually on the cross product side, the question will come on parallel lines. What happens in the case of parallel lines? Parallel lines will be sin theta is 0. Parallel lines. What will happen? Sin theta will be what? 0. Sin theta is 0 is basically meaning that A cross B is 0. Mod of A cross B is 0. Think about it. This will be 0 when? When this individual positive value will be 0. Because these are squares. Squares are never negative. Means you cannot add them to get 0. If they are 0 means that these values will be individually 0. Means this will be 0. This will be 0. And this will be 0 at the same time. All three have to be 0 at the same time. Then only we can say that mod of A cross B can be 0. Then only I can say sin theta is 0. Okay. So when you take this to be 0, check here. From the first one I'll show you. If I get M1 N2 minus M2 N1 as 0, what I get from here? M1 N2 equals to M2 N1. Bring the M1 on one side. So M1 by M2 equals to N1 by N2. And if you solve this one, you'll get a relation between what? L1 and L2 equals to N1 by N2. So basically you're going to reach over here. L1 by L2 equals to M1 by M2 equals to N1 by N2. So whenever you are talking about parallel lines, you're going to use this result in terms of direction cosines. Is it making sense now? This is not going to be making you worried, because this is of course there in the formula, but we never use it. We mostly use the condition for, in our syllabus, condition for parallelism. For parallel lines, sin theta is 0. Sin theta 0 means a cross b is 0. A cross b 0 means this whole root should be 0, and we have always square values inside the root, means all of them have to be 0. So basically what I get, that L1 by L2, M1 by M2, N1 by N2 is 0. In the case of what? Parallel lines, when the vector is what? Unit vector, or when you are talking about only direction cosines. Both the result are in terms of only direction cosines. Is it making sense now? Yes. Now we're going to move on to direction ratios. Same result you will be there, but instead of this value, you'll have what? A values. So you'll have what? A1 square, B1 square, C1 square plus A2 square, B2 square, C2 square. And if this is 0, beta, think about it. When they're perpendicular lines, what will happen? Cos 90 degree will be the what? 0. So this whole thing will become what? 0. I can bring this roots on this side, multiply 0. So I'll have the result as same. A1, A2, B1, B2, C1, C2 as 0. This is the result in terms of direction ratios when you have what? Cos theta as 0 means cos 90 as 0 in the case of perpendicular lines. Is it making sense now? Check. Condition for perpendicular lines, same. Mentioned over here. Have a look. For parallel lines, you're going to use the concept of what? Sin theta. You'll end up with the same result. Check. Okay? Getting it? Yes, sir. Find the angle between the pair of lines. Okay? Angle between them is given by using these lines. Okay? So I can use here cos of theta. Take the dot. 1 with minus 2, so minus 2. 2 with minus 4, so minus 8, and minus 2 with plus 4. That becomes what? Plus 8, no? Because you have minus sign over here. So minus 2 into 1 is minus 2. 2 into minus 4 is minus 8. And minus 2 into, again what we have? Plus 4. So again minus 8. Am I right? Correct. Divide by. Take the magnitudes. So we'll get here 1 plus 4 plus 4. Over here, 4 plus 16 plus 16. Am I right? 4 plus 16 plus 16. What I'm getting? Please check. Yeah. So I'm getting over here 2 minus 8 and again minus 8, right? Minus 2 minus 4 into 2 is minus 8. Just let me check the calculation once. And minus 4 into plus 4 will be minus 2 into plus 4 will be minus 8. So minus 16 and minus this will become what? Plus 18 divided by, this is what? 4 plus 4 is 8, 1 is 9, 3, and this will become what? 36. Correct, no? So 6. Okay, cancels. Answer is 1. So cos theta is 1 means theta value will be 0. Theta value will be 0. Simple question. I hope you got it. Next, the angle between the lines passing through the points from there. I'm looking for angles. So I have to find what? Direction ratios. Let's find out the first line. Let's call it to be AB. DRs of line AB. 4 minus 8 is minus 4. 6 minus 2 is 4. Minus 7 minus 0. So minus 7. Correct now? 4 minus 8 is minus 4. 6 minus 2 is 4. And minus 7 to minus 0 is minus 7. This is DR of AB. Let's find DR of PQ. Check. We'll have here minus 9 plus 3. So minus 6. Minus 2 minus 1. So minus 3. And 4 minus 2. So 2. Okay. Let's multiply these. So cos theta will be what? Check. 24 and minus 12 and minus 14, right? Correct now? Sorry, modulus. My bad. 24 minus 14, sorry, minus 12 and minus 14. That's going to be what? Minus 26. Okay, let's worry about that later. Over here, 16, 16 and 49. And over here, 36, 9 and 4. Okay, let me continue. Cos theta we have. I'll get minus 2 in the modulus because 24 minus 26 is minus 2. So I have that in the modulus. And the denominator you check. 36 plus 49. 36 plus 49 is what? That's going to be 36 plus, excuse me, sorry, 32. Sorry, 32 plus 49. That's going to be 81. Okay, so answer will be 9. Correct, no? This is 32 plus 49. Answer is what? 81. And root is what? 9. Other one is 49, so root is 7. 9 into 7, I get theta value as cos inverse of 2 upon 63. That's your answer. A. Makes sense, guys? Please have a look. I hope it makes sense. Please have a look. Yes? Clear? Moving on. Write the equation of the straight line through the point alpha, beta, gamma parallel to z-axis. DCs you write over here, z-axis. So we have 0, 0, 1. So we'll have x minus alpha by 0, y minus beta by 0, and this is y actually, and z minus gamma by 1. What do we have? 0, 0, 1. Option is B. Done. Now one more concept is there, which is about your shortest distance. Okay, this is also a very important question, whether it is board or CET. Student makes mistakes over here, so that's why it's very, very important to learn over here these things as well. Okay, again, this is something that is common between your vector relation also. Check this out. So if you have vectors given like this, so check here, if you have vector, first line is in a1 plus lambda b1, second line is a2 plus mu b2. Okay, then PQ will be the shortest distance between the two vectors or the two lines between L1 and L2, and you'll write like this: b1 cross b2 dot a2 minus a1 by b1 cross b2. The formula when you have two different ones means b1 and b2 are two different lines to which the line L1 and L2 are parallel. So line L1 is parallel to b1 and L2 is parallel to b2. In this case, you'll have b1 cross b2 dot a2 minus a1 upon mod of b1 and b2. But if you have the same line, it means the R is parallel to B, and even the first line R parallel to B. Means line L1 is written by this. This is your line L1. Okay, guys, and this is your line. This is your line L2. So both the lines are parallel to the same line. In this case, the result changes for shorter distance. B cross a2 minus a1 upon mod of B comes. This comes. Okay, and when you're talking about what? Line to intersect. If the line are intersecting in nature, what is that going to be a value of shortest distance between them? 0. D will be 0. In that case, what will happen? You'll put this equal to 0. This will be moved on that side, and this result comes from the case of when the lines are intersecting in nature. Okay, come on. Question on this. Shortest distance between the lines from here. Okay, first step is to find what? B1 cross B2. Let's find this value. B1 will be what? M1. So first we write I, J and K. Write this M1 10, M1 10. From here M2 10, M2 10. Check carefully. You will have only we can find across only K cap, because this particular column has 2 zeros. So I can simply use that last one, no, to avoid my waste of time in calculations. So M1 into this is M1 into 1, so M1 minus M2 is the vector B1 cross B2. What is the modulus in that case? B1 cross B2 modulus will be in the root square of M1 minus M2. That's it, because I cap and J cap are both having 0 as the components. So answer is what? Simply M1 minus M2. Answer is what? This is the modulus of B1 cross B2. Good. Let's find A1 minus A2 now. Let's find A1 minus A2. Check here. 0 minus nothing, so 0 only. Here also 0, and from here we get minus A and minus of A. This value is coming as minus 2A. This is your A1 minus A2, and this is again for K cap, because we have 0 I cap, 0 J cap, and only K cap is minus 2A. Distance formula, modulus of dot product of these two. Take minus 2A with this, you're gonna get the value as minus 2A into M1 minus M2. Modulus will be there, divided by M1 minus M2. Check. Of course, modulus is there. If you apply mod, you're gonna get this value as twice of A mod of M1 minus M2 divided by m1 minus m2 mod cancels. Answer is coming as twice of a. This is the distance, and that's my answer, which is option number C. Option number C. Was this a small and simple session or not? I have covered up all the concept in this chapter, which is going to be very important and on track for the PU2 boards and KCET. I mentioned one derivation is also coming from here, and one 3 marker can also come on shortest distance question. Okay, so this is the end of this lecture where I taught you the entire chapter quickly, and let me know what was your feeling about this class. We'll meet you again in the next class. Till then, take care. Bye bye.